153. So, ratio problems that cause issues, both because they involve fractions, also because they involve translating from words into mathematical symbols, which these guys problem sometimes. It's important to remember, though, that when we do math, it's not just about moving numbers around on a page. In reality, and we can use it to figure out things about the world around us. So, that's really a skill that is worth spending some time on. Both because it's useful for the class and also because it actually gives you that connection to reality here. My mother-in-law, who was a math major in college and then did a bunch of graduate work on computer science, she homeschooled all of her children, but she said that you don't really understand fractions unless you bake. And there's something to that. So go bake something if you're having trouble with fractions. Okay, ratios. Ratios. What do we mean when we talk about a ratio?
Like a set of numbers.
Like a set of numbers. Word set of numbers that means something specific that we're going to talk, well, we've already talked a bit about earlier in the year. We're going to talk more about later in the year. Ratio doesn't just involve some numbers. I mean, yes, it involves numbers, but what do we mean when we talk about a ratio? I'll give you a hint. There might be some answers here on page 153 in the textbook.
Fractions, decimals.
What's a ratio? Anybody?
It is a ratio.
Come on, look at the page. You have it there in front of you. The answer's right on there.
When we set the cross products equal.
What? No, you're just looking at random things on there.
An equation or statement in two ratios.
That's a proportion.
What is a ratio?
Another name for a fraction is ratio.
Thank you, a fraction. Ratio is a fraction. Remember? Remember?
Yeah, then you should have known it.
Remember, we talked about rational expressions. Algebraic expressions that involve fractions are also called rational expressions. Ratio, no expressions. A ratio. Usually, when we use the word ratio, we're talking about some sort of rather than it being a fraction, like 3/4 of a pizza. We're saying something like 3 pizzas for every 4 people, or something like that. But either one of those, we could write as a fraction, 3/4. A ratio. Now, proportion is when we've got 2 fractions that are equal to each other. So, for example, we can rewrite 3/4 as 15/20. Yes?
Yes.
Those are equal to each other?
Yes. Yeah.
This used to be a big thing on standardized tests, was these kinds of things with words. 3:4 as 15:30. The relationship between 3 and 4 is the same as the relationship between 15 and 20. Sorry, not 30, 20. Yes? Right? 3 and 4 are connected in the same way that 15 and 20 are connected. That's what this means. 3 divided by 4 is the same as 15 divided by 20. How can we check to see whether a proportion actually balances out? There's an easy way to check. Yes, you could simplify the fractions, but what's another way that you can see that a proportion is in fact balanced? These are in fact equal to each other. Anybody know how to do this? I'll give you a hint. They tell you on the page.
Multiply by 5. Wait, what? What was the question again?
How can we check that these two are actually equal to each other, other than by simplifying this fraction on the right? Obviously, if we simplify 15/20, we divide the top and the bottom by 5, we will get 3/4. But what other way can we do it?
Find the least common.
No. I mean, yeah, we could also multiply this guy up. But other than...
Times 4 times 15 and times 3 times 20, and then you get the same answer.
What? Say it again?
You should times 4 times 15 and 3 times 20, and you get the same answer.
Right. We can do what's called cross multiplication. We multiply like this. If we get the same result for both of those, then the fractions are equal to each other. What's 20 times 3?
60.
What's 4 times 15? Okay, so these two are in fact equal to each other. If one of those is greater than the other one, then that means that that fraction is greater than the other one. But if they're equal to each other, then the fractions are equal. It's a useful thing about the way that proportions work. We can cross multiply, and if we get the same product for both of those, then the fractions are in fact equal. Now, what this means is that if we've got some variables involved, we can use this to solve for variables. So, notice, if we have something like this, 7/5 equals 91 over g, how can we find a value of g that will satisfy this proportion, that'll make it true?
91 divided by 7.
400.
Cross multiply.
We can cross multiply. So, what do we get when we multiply g and 7? 7g. What do we get when we multiply 5 and 91?
455.
455. If, in fact, these fractions are equal to each other, the cross product should also be equal to each other. So it should be the case that g times 7, 7g, is the same as 5 times 91, or 455. Yes?
Yeah.
Yes? Okay. Now, once we get to this point, 7g equals 455. How do we solve that?
Divide by 7.
We just divide both by 7, and what are we going to get? Say it again? 65, yes. Right, because 7 goes into 45 6 times, leaving 3 over, and then goes into 35 5 times. Yeah, 65. G is equal to 65. We could then check our work if we wanted to, which is usually not a bad idea to check our work if we have the time to do so. By plugging in for that, 7 over 5 equals 91 over 65. And we can check that either by reducing this fraction on the right, multiplying up this fraction on the left, or by cross multiplication. So we should get, these two should be equal to each other. So let's see, 65 times 7 will give us what?
445.
4 what?
455.
Yeah, 455, and 91 times 5 gives us, look at that, they are equal to each other. Ka-ching!
Yeah, why can you make the money sign if you put a check mark?
Ka-ching!
Okay.
All right, is that better?
Yeah.
All right, good.
How about the 7?
No one actually.
Ka-ching! That's a much smaller. We could do like euros or like pounds or something. Or,
Oh my goodness.
Wait,
You mean the inferior dollar?
anymore?
not very frequently, no.
Wait, what?
Signs? Like signs?
Oh.
I mean,
Alright. Anyway, okay, that's cross multiplication. So anytime you have one of these, you can solve it that way. Now, let's see what this looks like in a sort of real world context. So flip to page 154. We're going to see how this might look as a word problem, setting this into some sort of real context. Okay, so example 38.2, the top of 154. The ratio of pigs to goats in the barnyard was 7 to 5. If there were 91 pigs, how many goats were there? Now, pigs to goats, right? We can abbreviate pigs with P and goats with G. The ratio of pigs to goats. The ratio of pigs to goats means ratio of fraction where pigs are in one part and goats are in the other part. Now, pigs to goats, what's the ratio of pigs to goats?
7 to 5.
Is 7 to 5. Now, don't get this mixed up. Don't get this mixed up. When they say pigs to goats is 7 to 5, that means that pigs, when they say pigs first, pigs to goats is 7 to 5. Don't get it mixed up. You could do it the other way around. You could say goats to pigs is 5 to 7. But whichever one they say first has to go with the first number for the ratio, and whichever second goes to second. If you write this, that's something very different. That's the ratio of pigs to goats is 5 to 7. Remember, these are fractions, so the order does matter. They say the ratio of pigs to goats, and the easiest way to do this is just do it in order top to bottom. The ratio of pigs to goats is what? 7 to 5. So 7 goes on top and 5 goes on the bottom. Yes, pigs to goats equals 7 to 5. You see how I translated that into mathematical symbols? Okay, now what do they say? If there are 91 pigs, how many goats were there? So now what am I going to rewrite here?
91.
Right, 91 over G. Because pigs, we know how many pigs there are. We don't know how many goats there are, but we know that the ratio is 7 to 5. Right? They tell us the ratio is 7 to 5. For every 7 pigs, there are 5 goats. If there are 91 pigs, how many goats are there? Look, we already solved this particular equation. So how many goats are there? Yeah, there are 65 goats, because if we cross multiply, we'll get 7g equals 455, and then we divide by 7. Yes? Yes? Okay, let's do one more. Example 38.3. In the same barnyard, not that that's relevant, the ratio of chickens to ducks was 9 to 4. And there were 108 chickens. How many ducks were there? So how am I going to set this up? The ratio of chickens to ducks was 9 to 4, and there were 108 chickens. How many ducks were there?
C over D
Yep.
equals. Wait, what was it?
It's on 154, middle of the page.
9 to 4.
So C over D equals what?
9.
9 over 4. Chickens to ducks is 9 to 4. The ratio is 9 to 4 for chickens to ducks. All right, then what do they tell us?
108.
Okay, so what am I going to write now?
C of 108 over D.
108 over D equals
9 to 4.
9 over 4. 108 chickens, because chickens, we know there's actually 108 of them. We don't know ducks. All right, now what do we do to solve this?
I think it's, yeah.
Yeah.
What do we do?
Then
How do I solve this? How do I solve it?
432.
We cross multiply. What do I get when I cross multiply?
432.
4 times 108 gives us 432. 9 times D gives us
90.
90. Okay, now what do I do?
Divide by 9.
Divide by 9. All right. What do I get?
Hold on a second.
T equals. I can do that.
How many times does 9 go into 43?
43?
Yeah.
4.
4 times, which would give us what?
7 left over.
4.
Which would give us 7 left over.
Not
Okay.
49.
So then 9 goes into 72 how many times?
Mm-hmm.
9 goes into 72 how many times?
Not 8. Yeah.
You guys know this trick, short division? You familiar with that? Maybe a quick refresher here, no pressure refresher. We're doing 432 divided by 9. 9 goes into 43. How many times did we say? We know it can't be 5, because what's 9 times 5?
4.
45. So it's got to be 4, which leaves how many left over? At least 7. So we just write the 7 here, like a little 7. We know. Then we say 9 goes into 72. How many times?
8.
8. Okay. All right. So how many ducks are there?
48.
48 ducks. Look at that. If we wanted to check our work, we could plug it back into this ratio. 108 over 48 equals 9 over 4. And we can either simplify this fraction, multiply this one up, or cross multiply, and we'll get our answer. Yes? Capiche? All right. I think that's
That's a lot of ducks.
a lot of ducks. Yes. The key with these, listen, is setting them up correctly. Use abbreviations here so you keep track of which one, and just write them in order. Whatever they say, here they say chickens to ducks, but chickens on top and ducks on bottom. And then they say the ratio is 9 to 4, so 9 on top, 4 on bottom. You have to do them both in the same order. You could do it the other way around. You could write, if you wanted, D over C equals 4 over 9. In fact, that's what they do in the textbook. But don't do that. There's literally no reason to do that. You're only going to confuse yourself. It's not any easier. You might as well just write these things in the same order that the information is given to you. They say chickens to ducks. Just do chickens to ducks. Don't do ducks to chickens.
Okay.
Okay?
Will you get the same answer?
Yes, you'll get the same answer. Yep, it'll work exactly the same way.
No, wait.
But,
why do they flip that?
Hmm?
Why do they flip it?
I don't know. I don't know why they flipped it. You can if you want to, but there's no reason to. It's just going to make it more likely that you'll make a mistake. All right, get started on 38.
Can we get a paper?
Yeah, I'll give them to you in just a moment.
Yeah.
38, you're going to do all except for
That one.
4,
No, all except 5 and what is it, 29?
5 through 30. That's all except
5 and 29.
5 through 29, please.
Well, I said 29, wrote 28. All right, all except 5 and 29.
Oh,
He said
5
and 29.
All the